Hi, everybody. We're the Skeleton Crew, and today we are going to talk to you about what I suppose is the smallest dinosaur in the game, right? Or I guess tied for that maybe with Sinosauropteryx.
I actually don't think it is anymore. I think it's roughly on par with, if not... Oh, yeah, no, I think Microceratus is smaller. I think so. But I think also the Segisaurus model is really... It's close to as small.
Well,
right. I forgot
in any case, it's a little guy.
Little guy.
It's a little guy. His name is Compsognathus, or Compsognathus, depending on how you pronounce the word. But in any case, there's only one way to pronounce our channel name, and that is the Skeleton Crew. As we learned shortly before recording this video, apparently our next episode will be directed by Bryce Dallas Howard.
I'm excited.
We've been waiting to break this news for a while.
Yeah, it's very exciting for all of us here. A few things before we get started. One, if you like our videos, if this is your first time seeing us, welcome. And if you like this video and you want to see more of them, please hit subscribe. We've got a huge backlog of videos for you to get started watching, and we release new content roughly once a week, but a lot of weeks have bonus stuff. So if you subscribe and hit the bell, you'll be notified every time we upload a new video. As always, if you enjoyed this video, please leave a comment, drop a like. All of this stuff really helps us out. Second, if you really like the Skeleton Crew, there are two things you can do. One is that you can support our mission to make more science communication content that is brought to you directly by experts in the field. Right? We are all working scientists, so we are trying to tie in what we know from how we do our work into SciComm Online. We have both of our jobs simultaneously, and so any amount of support really goes a long way. And so we have a Patreon, where if you really like the stuff we make, or you think that what we're doing is valuable, we'd really appreciate a little bit of support there if you can.
Thank you.
You get a whole bunch of perks if you support us on Patreon, and we thank all of our patrons now and at the end of the video. Two, we have a lot of leftover pins from our appearance at Midwest Gaming Classic last April, and they are currently for sale on our Etsy store. About half of our stock has been sold, and when they are gone, they are gone. So get them now if you want to rep some beautiful enamel pins on your own personal belongings. They are incredible. They look great, and I might buy some.
And I think
I might transfer money between multiple pots here and just buy some pins. But
and
we'll see.
I think we had a purchase, Amelia, from a friend of mine.
Yes.
I think bought one. Yes, he cut our live stream.
Oh, no way! That's super cool.
Yeah, no, it was very cool of him. That was all. That's all I had to say. Should we dive on in?
I think we should dive on in. Well, yes, we should introduce ourselves. So the person currently speaking to you is me. And me, as of right now, is Dr. James Napoli. That's actually not going to change. That will be my title until I die.
Unless, of course...
unless you really mess up.
I don't know. Has anybody had a doctorate rescinded where they're just like, you're too stupid now? You can't use this title.
I don't know if it's because,
anymore?
Yes.
It's usually not because you're stupid, but I'm pretty sure you can get doctors.
Yes.
Okay. All right.
There was a little.
I guess that was a dumb question.
There was a little documentary I watched a while ago about a guy who, the guy who faked an element in like the naming element races.
That's so cool.
Yeah.
Awesome.
It's a really, really cool video that I won't get on it, but like watch it. It's fascinating, and they rescinded his doctorate if memory serves.
Huh.
I invented new elementium.
Well, all right. I'm not going to fake a new element, and so I think I will remain for the rest of my existence on this earth, Dr. James Napoli. I am a research instructor at Stony Brook University's Renaissance School of Medicine, where I teach anatomy to medical students and students in other health sciences professions. In addition to all my research, just to be clear.
You still have people getting confused. My name is Amelia Zilo. I'm a PhD candidate for the foreseeable future at the AMNH's Richard Gilder Graduate School.
My name is Scott Johnston. I am the vertebrate paleontology, fossil preparator, and technician at Harvard University's Museum of Comparative Zoology, where I shall remain.
Thank you, Scott. I'm Alex Rubenstahl, a PhD candidate at Yale University, and also an aspiring Elden Lord, because have been playing and I'm not currently playing Shadows of the Erd Tree, which is very good.
And I am the voice that has not been speaking to you yet, but is now speaking to you now. And that voice belongs to Dalton Meyer. I am also a PhD candidate at Yale University. And together,
we're the
Skeleton Crew.
And have we got a little guy for you?
We are the Skeleton Crew.
Let's release the folks.
Folks,
Folks,
we're
you
releasing
say.
them.
They're folksy.
Look at them all come out. There's so many of
There
them.
are so many of them. They hop around.
They
What
zoom.
would you...
I like that they skip. Like, they don't just hop, they specifically skip. They alternate feet.
What would you call a group
so
of
cute.
Compsognathus like this?
A menace.
Hmm.
When you
A
do.
plague,
I
maybe.
really like them.
They're very cute. They have so much personality.
They're
It's
adorable.
They're so cute.
They're just a cute little guy.
The little noises they make, too. This is just... Oh! They're having a little disagreement.
It was civil at the end of the day.
Oh, yeah. I love these guys so much. I love that they're simultaneously like one of the smallest animals featured in the entire franchise, and without exception, always depicted as a bastard.
Yeah.
Like, even in I recently, over the last like week or so, watched all of Camp Cretaceous so I could watch the new Chaos Theory, and Compsognathus features very heavily in there. There is not a single time that these things are on screen that they aren't causing problems on purpose at any point in this entire franchise. And I love them.
You know, in reflecting, and this is not a negative or positive statement, it's whatever you'd like it to be, but I think, at least in the film canon, these animals have killed more people than the Giganotosaurus.
Oh, definitely. Absolutely. 100%.
Which is wild.
Is it infinite percent? Because does the Giganotosaurus kill any human being?
No.
No.
I do not believe so. So I think it is infinite percent, because it's what? Well, one person.
It's
in,
Dieter. Yeah.
Yeah,
and they
one
mess
person in
up
the
that
Lost
little
World.
girl.
And they mess up the little girl.
Yeah.
It's one person in Camp Cretaceous.
Oh, they got bodies in Camp Cretaceous?
Oh, yes, they do.
Lamau.
Several, actually. But yeah, no, they kill someone in Camp Cretaceous.
And if you
Wild.
want to go
It actually-
that way, in the book too.
Oh, in the book too.
Don't they kill Hammond in the book?
They kill John
Yeah.
Hammond. Yeah.
Well, those are Compsognathus, which
Sure.
are, for our viewers who may be confused, a coelophysoid, more like Stegosaurus.
Yeah, these guys are just amateur Compsognathus, so.
Right.
That was pretty good,
Well,
Scott.
that's a decent segue into what does their name actually mean. Is it
Yes.
amateur Compsognathus?
It is not. It apparently means. So, there's several translations of the compso part. I think the funniest is dainty, because then it means dainty jaw, longfoot, which sounds like a bad pirate name.
Sounds like a warrior cat name.
Oh,
my
it really
God.
does.
Oh, Dalton, that was a deep cut.
I would edit that out of the video if I were editing it and I had said that.
I'll clarify. I've never read a warrior cat's book. I just am aware of the nature of their names.
He has a
Wish I
pretty
could say
natural
the same.
sense.
This one, I like this one. This one looks like that, that stuffed dragon toy that's at arcades all the time. That's like blue fade to yellow or whatever.
Oh, yeah,
with a bit of
yeah.
purple and stuff. It's like dead on that.
Oh, look at him go.
Putting them in
He's so
slow motion
fast.
is almost just makes them look like they're moving at normal speed.
Right? They're so frenetic. I love them.
They're varmints.
They are varmints.
The noises they make are
in
great.
Red Dead, you would hunt them with the varmint rifle.
You would indeed.
And then
I
I'd
agree
feel,
with that statement.
I'd feel bad about it because I don't like hunting or skinning the animals in the game.
Isn't it like supposed to be a diagnostic trait of sociopathy that you feel bad only about killing animals?
I don't think that's true. I think that's something people who don't feel bad about killing animals have made up to disparage us animal not killers.
It's actually it's a Tony Soprano-opathy.
How?
Also,
That's a good point.
also, if we're being 100% for real, if these were in Red Dead, you wouldn't skin them. You just throw them entirely into your satchel.
I don't know. They're about the size of
the black hole.
I guess you pluck them like the birds.
Oh, yeah.
Anyway, yes. But thank you for explaining its name to us, friend Amelia.
Yes.
Well, that would be the name of the only now valid species. There, technically speaking, have been 2 proposed species of Compsognathus, with the second one being named significantly after the first. The first one, so Compsognathus was discovered quite a while ago, back in 1859. And for a while, it was one of the best known, if not the best known, non-avian theropod dinosaur.
I think it was probably found before the understanding of before theropods were named, right?
I don't know. Oh gosh, when was theropods named? Well, because originally it wasn't even thought to be a dinosaur. If memory serves, I think it was originally thought to be a weird lizard.
Correct. 1881 is Theropoda.
Yeah, so way before.
Oh, significantly. Well, there is debate over where and when it was actually found, because apparently the guy who found it was incredibly secretive on where it actually was from, because he didn't want other people to go find more.
And that's not
a secretive
uncommon
paleontologist?
Well, that's not uncommon with the Solnhofen stuff. At least
true.
Early on, the exact whereabouts was pretty...
Yeah, it was discovered by Joseph Obendorfer. Oberndorfer.
Were they a most German name competition?
They really were.
That's the sequel to Oppenheimer that Chris Nolan is making right now about the discovery of Compsognathus.
But it is a stunning specimen. And like it includes almost the entire thing. And then many, many years later, in 1972, a second individual was found, and it was named as a different species, Compsognathus coralestris.
Coralestris.
Oh, sorry. I legitimately misread that.
You're
coralestris. And that was discovered near Nice in France.
Nice.
And indeed, which I have to say, made it really, really difficult to try to find good pictures of it, because I was looking up Nice specimen of Compsognathus, and it was just all of these things. Look at this nice picture of Compsognathus. I was like, God damn it.
That is pretty funny.
But
cannot lie.
Back onto what I was saying before. There was a second specimen that was found in 1972 that was named Compsognathus coralestris. This has... Okay, let me get my thoughts together about this for a second.
Gather.
So, with Compsognathus being one of the most well-known dinosaurs, both for theropod dinosaurs, both for being incredibly well preserved and very complete, and also paradoxically being at the opposite scale that we normally think of things being memorable in Dinosauria, being the smallest one for a very, very long time, made it so it was very popular, and it was a very common dinosaur depicted in a lot of things for a very long time. Especially, it got some really weird interpretations, even though both of the specimens are very, very complete and very gorgeous. The first one, both of these kind of stem around the forelimbs of the animal, which I think is kind of funny because like it is like the only bit of both of them that aren't really well preserved. Growing up, I saw 2 weird interpretations of how Compsognathus would have looked when it was alive. First, I saw a lot of depictions of it having tiny little 2-fingered hands, like a tiny little tyrannosaur. And that one actually...
And there's good reason for that, yes. I mean,
yes.
Not that it's correct, but yeah, you're right. That just wasn't people being weird.
No, that one wasn't people being weird. That was that the third digit just is not preserved, and it was interpreted that it was reduced or lost. So it makes sense as to why people like Ostrom would think that it had lost that finger.
Right.
The other one makes way less sense. The other hypothesis that
but you slander the hypothesis.
I will slander this hypothesis all I want because it's very silly. So the other hypothesis basically proposed that one of the other things that differentiated the two species of Compsognathus, and namely differentiated Corylestris from Longipes, is that Corylestris had a very weird adaptation for its particular lifestyle. Namely, it had adapted its forelimbs into flippers to be a semi-aquatic, like near shore bird, basically.
But Scott, I don't see flippers on our model. Did that interpretation not hold up?
You know what? Do you know what's really interesting as well? Because like how you don't see flippers on our model, I also don't see forelimbs on the specimen that they are referencing for this. Really? So I have always been puzzled by this because it was a weird little thing that would pop up in some of my older dinosaur books growing up, that every once in a while you'd see an absolutely goofy looking little Compsognathus that was, and I'll throw this in our chat because we're doing this.
Yes, for those of you who have always wanted more questions or more images and Skeleton Crew videos.
We're trying.
We now have an editing process. We're trying a new thing to make sure we add more pictures. We do listen to your comments.
So, as you can see in this image, what were they doing? And I like that this one very helpfully shows the two different species of Compsognathus. We have regular, normal, decent-looking Compsognathus
God-fearing,
and weird Cronenbergian fish monster Compsognathus. So I was very curious as to where this goofy idea came from, and it actually came from the description of Compsognathus corylestris. So in that paper, in the section on the forelimbs, they mention that the arms are very shortened, and indeed, in Compsognathus longipes, it appears not to terminate in 3 digits fused with well-marked claws. There exists perhaps 1 or 2 other digits, functional vestigial, that do not appear for observation. This type of organization of the manus conforms to that known in other bipedal dinosaurs, such as Duthiomimus. It is presumed for forms close to Compsognathus, Sigisaurus, Ornitholestes, etc. In Compsognathus corylestris, it seems this arrangement was different. The presence of dermal bone at the level of the forelimb and manus would imply an ankylosis of wrist articulation. In these conditions, the anterior part of the limb, far from being adapted to seize prey, has undergone a transformation into the form of a rigid aileron. This adaptation, hitherto unsuspected in theropods, would not contradict the ecological framework of this dinosaur. However, it would not involve envisioning the realization of a swimming paddle, which would imply a shortening of the limb bones and a hyperphalange, not observed here. At most, a role as an oar would be admitted for the forelimbs. We are moving these goalposts and being incredibly pedantic. No. A paddle is ridiculous.
An oar.
An oar, though.
This is coming from the same people that made this drawing.
No. This is the drawing that I posted is from a book. This is from the description.
I see. No, I was just wondering if these were the same people that labeled a horseshoe crab as a king crab.
No. It's not from those folks. But I find that sentence. This is going in the theme from last week's episode of "Ain't that incredible?" type. Ain't nature amazing type paleontology.
Well, I mean, Scott,
nothing like this has been seen before or proposed, but isn't nature fantastic? Yes,
it's
go
interesting.
On, Alex.
This is interesting because while a silly, ridiculous hypothesis, that we're having a bit of fun at the expense of. It did. I think it was briefly revived by the bandits, with the description of Sinosauropteryx when they were
bandits.
Birds are not dinosaur people.
We may not have ever talked about those people on the channel before.
Here's a very brief history lesson for our viewers. In the 90s, let's say mid or early 90s, up until functionally the mid 2000s, they're irrelevant really at this point. But there was a very small vocal minority who did not agree that birds descended from theropod dinosaurs. They labeled themselves bandits. Birds are not dinosaurs. There was, when Sinosauropteryx, a little Compsognathus, which we've talked about, and the first feathered dinosaur really described, was found. It had that crest of feathers that went down its back that were interpreted as a collagen, like a skin fan, basically. And I think, if I'm remembering correctly...
Like on the Deinonychus game.
Yeah, like that. And if I'm remembering
it's actually a deliberate reference to that, I'm sure.
Oh, maybe. But was thought to be it's been proposed that Compsognathus was semi-aquatic. So perhaps this was a swimming adaptation.
I want to draw the viewer's attention again to the fact that part of the forelimb is not preserved.
Well, I wanted to
Well, the forelimb is preserved.
On the specimen in France?
Yes.
So there is.
It does.
I think, not to give tremendous credence, but especially to the drawing that we looked at earlier. I've just shared an image, a photo of the Coralestris, in quotes or whatever, specimen, the French specimen. And in this photo, there are some marks in the sediment around the distal end of the forelimb.
Yeah, those are imprints of the metacarpals that I believe are on the counterpart of the slab.
But to the untrained eye, I can see looking at that and being like, oh, that kind of looks like a flipper.
I mean...
I can't. I simply wouldn't.
Dalton also, I can see why the untrained eye would say that. But this is a hypothesis from the description of this.
No, yeah, I'm not trying to say they were right, but especially with respect to the drawing, I can superimpose that and definitely see, if you were an artist and were like, oh, hey, scientists think this thing may have had webbed digits or a flipper, and then they show you this photo, you're like, oh, I can kind of see the outline of the flipper. I'll just do that.
Okay, that's fair. That's fair.
And so at some point, it became interpreted that these are not two different species, but these are just two different individuals of the same species, right?
Yes. That was in Ostrom's paper. Actually.
And it should be noted, and we have said that Coralestris is much larger than the other one, right? That's been said? Okay, good.
It's approximately 50% larger, which...
Still a little guy.
It's still a little guy, but if you look at size comparisons... It's quite a bit bigger now. It's approaching the size of a small a small goose from chicken sized, which that it's still a small animal and very lightly built, but it's a bit bigger than I always kind of pictured it.
I mean, if it was goose sized, it's really into the territory where it could be a total bastard. Yeah, just
yeah.
Such an evil animal.
Well, I guess if this guy definitely wasn't paddling around like a weird duck boat thing, what was this guy doing? How was this guy living? Dalton, I think you know quite a bit about this.
I do, because it was running around like a menace, chasing God's preferred and better creature, the lizard.
Wrong.
It's interesting that both specimens of Compsognathus preserve at least ostensibly lizard remains in it. So Compsognathus longipes, the holotype, has definitive lizard bones in its gut. And interestingly, for a long time, those were referred to Bavarisaurus. So John Ostrom really kind of led the first ID push for what actually did Compsognathus eat. And he referred the lizard in the skeleton of the holotype to the genus Bavarisaurus. which is another genus of lizards that's found in the Solnhofen limestones, which we'll get to that in a moment. But in 2018, a paper was published that erected the lizard within the gut contents of Compsognathus as the holotype of a new genus and species, Schoenesmal dyspepsia, a name that translates to beautiful meal.
It's such a good
Schoenesmal
name.
means beautiful meal, and dyspepsia is like indigestion, kind of. So it is a holotype within a holotype, which is a certain rarity. I don't actually know if I can think of any other holotypes in holotypes.
That's so cool.
There has to be a weird, like, specific, never used, like, something type name for that.
Gastrotype.
Internotype.
Ooh, I like that.
I like that a lot.
Yeah.
Would it be endotype because it's inside?
Endotype. Yeah, there we go.
You guys want to write a little paper?
There we go. Yeah. Put me in the acknowledgments.
But the Coralestris specimen also has gut contents that are referable to some small reptile. I can't find any source that identifies them to any degree of particular certainty, but they're probably either a lizard or some kind of small sphenodontian. There are, in addition to lizards from the Solnhofen, of which there are 6 known species, there are a large number of rhynchocephalians known from the Solnhofen, and those include things that look a bit more like modern tuataras, things that are a bit more lizard-like in appearance, like Homoeosaurus, and then also the semi-aquatic, or sometimes I think considered fully aquatic, pleurosaurs, which are long and skinny and strange, and they're swimming around. But Compsognathus, it could probably swim, but I don't think it shows any adaptations for making its living by swimming. It seems to be a small terrestrial predator of small terrestrial or possibly semi-arboreal prey. Although if I had to guess, it's mostly that the lizards are running up trees to get away from Compsognathus.
I would bet so. Because this guy is not, like, derived enough in dinosaurs to have, like, little flight feathers on his arms to do, like, wing-assisted incline running up trees and stuff, right?
No.
I mean, probably could climb a little bit.
Yeah, I wouldn't
wasn't doing that.
Yeah. Most animals can do a little bit of most things, but no degree, like no obvious specialization for that. But Compsognathus was just one small part of a larger ecosystem, and that ecosystem is the Solnhofen archipelago. So at this time, in the late Jurassic, Western Europe and kind of Central Europe is expressed on Earth as a series of islands. So you kind of famously get a glimpse of some of what this environment might have looked like in the Cruel Seas episode of Walking with Dinosaurs. It gives you some idea. But if you imagine a pretty warm, tropical-ish kind of atoll, that's pretty much exactly what you're looking at. You've got lots and lots of small islands interconnected by shallow lagoons and bodies of water. And these supported a tremendous amount of life. The Solnhofen is what we refer to as a Lagerstätten, which is a word that means burial place. And we use it to describe fossil sites of particular note in either the quality or quantity of preservation. And Solnhofen is known for its quality of preservation. So there's actually, it's not like extremely, extremely fossiliferous, these limestones. But the fossils that we do find are beautiful, and we end up finding a lot of them because there's a lot of people churning through these limestones because the actual rock itself has a lot of commercial uses. Famously, it's referred to as a lithographic limestone because the actual rock itself is really good for producing lithographs. It's got this really fine-grained texture. It's these carbonaceous mudstones and siltstones that are laid down and they're laminated. And because they're fine-grained and they're laid down in that manner, they also preserve things with a really high degree of fidelity. So you get things that you don't often see, like the feathers on Archaeopteryx, which is from this ecosystem, like pterosaur wings and pterosaur feathers, like you see in several of the specimens. Things like the wing membrane of Rhamphorhynchus, right?
Muscles and skin, yeah.
Mm-hmm. So it facilitates really exceptional preservation of these specimens in terms of both the kind of size factor, right? Like this is rebuking the typical taphonomic bias of the Mesozoic of preserving big things, and that this preserves a lot of small things. And it's also preserving a lot of soft tissue. And beyond the dinosaurs, beyond Compsognathus, there's also, within dinosaurs, you get things like Juravenator, Cyuramimus, things like that. You get a ton of pterosaurs. I don't remember the exact number offhand, but I think it's like 20 plus species of pterosaurs out of the Solnhofen. There are, like I said, 6 species of lizards, which is unusual for the Jurassic, and especially because they're mostly complete. You get a number of sphenodontians. There are also tons of invertebrates. There's these beautiful shrimp, horseshoe crabs. You get fish. You get sharks. Pretty much all
Aren't
the
there
stuff.
jellyfish in the Solnhofen? Or is that somewhere else?
Don't recall if there are There are definitely like soft tissue squid and cephalopods in Solnhofen. I don't know if there are jellyfish, but there could be.
Some nice belemnoids, right?
Yeah. Mm-hmm. This is where there's famously a specimen, I think of a belemnoid, but it may be a squid, I don't remember, that preserves the ink in the ink sac.
For our viewers who aren't invert people, a belemnoid is basically a squid, but they have these kind of conical internal skeletons that are called belemnoid. What are they called? The rostrum, right?
Yeah, rostrum. Mm-hmm.
That are like the internal skeleton, whereas squids have only a very thin little pen.
Yeah, they're very cool. But you get lots of... Oh, sorry.
Side note, there are jellyfish.
That's really cool.
Yeah.
So
that's freaking sick.
You might be noticing that these are mostly marine things, and then also things that can fly. There's some insects. There's a beautiful, beautiful dragonfly that comes from the Solnhofen. But you're mostly preserving marine stuff. You're mostly preserving stuff that lives in the water of the lagoons. And then you're also getting occasionally stuff that's falling into the lagoons. And also things that are flying over the lagoons, dying and sinking in. And one of the things that's helping to facilitate the excellent preservation is that occasionally these lagoons can become cut off from the sea. And in doing so, they can become hypersaline. And there's also the possibility that's been invoked of some bottom water anoxia, so that there's less oxygen at the bottom of these isolated lagoons that are cut off. And because you get they get a lot of salt, you potentially get no oxygen. You're really limiting the action of scavengers and other things that are going to come and break apart carcasses. And then you combine that with the really fine grain sediment that's just kind of raining down in these lagoons. And that creates an environment where you have the potential to preserve really, really beautiful specimens.
Yes. It's probably worth pointing out that these anoxic conditions are also responsible for exceptional preservation at other places like this, like the Yixiang in China, and also Green River, right, is an anoxic lake bottom.
I believe it's a series of anoxic lake bottoms from, Yeah, and I mean the occasional material that's been found in New England associated with the Rift Lakes, right? with the Rift Lakes there.
Redfield is right.
Yeah, not a lot has been found because there's not a lot of extensive rock outcrops, but from what fossil material has been recovered, it seems that you'd probably have a very high quality depositional environment there too.
Cool.
Beautifully preserved fish. I'm sure one day somebody's going to be digging like a new wine cellar or something, and when they are excavating for the wine cellar, they're going to find like a beautifully preserved small feathered dinosaur.
With any luck, something that'll be our wine cellar. We're digging as a group, the Skeleton Crew Mansion Wine Cellar.
Yes, please support us on Patreon.
You know how
so we can all move into one house together.
All of the influencers have their LA hype house like big McMansions. We're going to have the Skeleton Crew hype house, and it's going to be a New England old world mansion.
That's going to be awesome.
James, I just had the thought of if at some point during our future careers, one of us is able to found a museum and like start a museum, we would and all of us end up working there. We would just call it the Skeleton Crew Hype Museum for the rest of time.
This is our hype museum. Just a side note for everybody now, I have completed doing science. And so when we are ready to do Phylogenum, I should be ready. And I'm actually finding some interesting things. Believe it or not, it looks like this placement of Compsognathus is well supported.
Oh, you don't say.
Well, before we do that, I have a character I want to play for a little possible lead-in bit here that has to do with the depositional environment and preservation and stuff of these guys.
What's the character you want to play?
So I'm going to be asking. So, all right, if we're finding all of these incredibly well preserved animals in the Solnhofen, like jellyfish that obviously don't have bones, pterosaurs with their wing membranes preserved, multiple Archaeopteryx. Why is it that both of these specimens of Compsognathus didn't have any feathers preserved? Does that mean that these were non-feathered little Silurisaurs?
No, you absolute dope.
Bad luck, I would say.
Yes. As Dalton alluded to earlier, or maybe it was Scott, who mentioned Giravinator?
I mentioned Giravinator.
Dalton did.
This is a little dude that appears to have, when it was first described, had a little scalation that was preserved, and everyone was like, oh, whoa, this is weird, because it was discovered after Sinosauropteryx. Later,
it's 2006 or something like that.
Yes,
right?
Although I think later investigations would reveal that there is also filamentous integument on the specimen. So it's possible, and things like Cirrhomimus, you do get Compsognathids and small weird theropods that do have integument, but yeah, like Dalton said, it seems to be a case of bad luck, bucko.
Yeah. There are some Archaeopteryx specimens that are referred to Archaeopteryx that have piddling to almost no feathers preserved.
So I think they were...
Yeah, whatever precise taphonomic processes we're operating very locally at any given point in like place and time. And it is, to a degree, even with this tremendous opportunity to preserve, still a bit of a game of chance in terms of exactly how much soft tissue you might preserve, given the like ability to do so. So I wouldn't take it to make any conclusions about the integument of Compsognathus.
I have also heard, because at least, I've seen some depictions of Giravinator specifically, because, correct me if I'm wrong, Alex, but
I will.
I think that I don't need to give you permission. I should know you better than that. The scalation preserved on Giravinator is mostly restricted to the tail.
Yes.
And I've seen some interpretations, some life reconstructions of Giravinator that give it a gross little rat tail. Like it's otherwise covered in like kind of shaggy little proto-feather, but has kind of a weird, mostly hairless, but kind of sparsely hairy rat tail.
Yes.
Which is gross, but I guess not implausible?
No, I mean, there are numerous mammals that really have either strongly reduced or completely absent, like scale-tail rats and stuff like that.
No, opossums.
Yeah, no, absolutely. And like, again, our understanding of like what the actual interaction of scales and feathers in dinosaur integument is pretty limited. And so I always maintain that in little patches, the presence of one thing doesn't necessarily mean the absence of the other. But, most reasonable inference.
Yeah. The other thing to keep in mind with this, understanding the taphonomic window that we have at Solnhofen, is that while it is breaking biases that you normally have in most Mesozoic rocks, hey, we're getting small stuff and we're getting really high fidelity preservation, that doesn't mean that it itself doesn't have biases of its own. It is not free from bias. What it does mean is that, like, hey, we're seeming to preserve all this small stuff. What we're not preserving is big stuff, right? We haven't found a Solnhofen sauropod or like large theropod or any kind of like carnosaur like of big size. We seem to be just finding this small stuff, and that is, I would not treat that as, oh, this is like a weird, like these are little islands that are populated only by small animals. It may have certainly been the case that some of these lagoon islands were small enough that they couldn't support like a humongous animal. but I don't think we have certainly well enough constrained like how big each island was, how easy it would be for animals to cross them. Excuse me. And the lack of finding of big dinosaurs in the Solnhofen should not preclude you from thinking that they were around in this area at this time. They just are not being captured in this particular window that the limestone is preserving.
Yeah, no, absolutely. And we know like at least large theropods are capable swimmers based on like those trackways, right?
Mm-hmm.
Oh yeah, there's several swimming theropod trackways.
So yeah, Compsognathus was probably not, the only or biggest predator in its environment. That's all we're saying.
Yeah.
Maybe you stripped a spondylus.
Yeah.
Well,
this swims up there and eats one before getting absolutely wrecked by a leopard.
They didn't live together, Scott.
Walking with dinosaurs.
No.
We mentioned it earlier.
No, I didn't mean it.
Wee woo, wee woo. It's the fun police.
So there is one thing that this discussion brings up, though.
Oh.
I've heard it. I'm gonna play a character for a moment as well. This is actually an acting class here. Yes, I know, me playing a character.
Well, you have taken film classes. You know how to act.
Indeed. Back in my halcyon days as an artiste. So I've got a question for you, Dalton.
What's your question?
Given that compsognathids are very small, would the fact that they're present on these islands not be evidence that they are juveniles of larger carnosaurs that must have also been present on those islands?
I would not take their size alone as face value. I will say this.
Yes.
Having not studied the material directly, I would look for other evidence suggesting immaturity before making such a claim. Because they could just be small.
They could, and in fact, they are. So I think.
Are you sure about that? I thought dinosaurs were supposed to be big.
I know, but famously,
ridiculous.
Yeah, this sounds fake. The deep state is making up fake dinosaurs.
Big paleontology.
Small paleontology in this case.
Small paleontology.
There is an idea that I've seen floating around in like online communities recently, and I mean, not just me. We've all seen it.
We've all seen it.
Oh, we have.
That these small-bodied theropods are not really constituting a natural group, and that the fact that they are forming a clade together is a result of them just being young animals.
Mm-hmm.
There's a lot that we at the Skeleton Crew could say about this, but I believe we will be saying stuff about this hypothesis in a more formal setting, and so we're going to keep our comments here fairly brief. But you may have noticed that I've been kind of quiet in the first half of the video, and that's because I've actually been doing some science. I've been reanalyzing an old data set just to see what the data would actually say about this. And this is published data. You could do the same thing. So I ran the analysis matrix from the paper describing Curricula, which is the most recent published iteration of the theropod working group phylogenetic matrix. This is often abbreviated as TWIG. This is something I'm sure you've heard us mention in prior videos before, but I don't think we've ever defined it. So the TWIG matrix is a phylogenetic analysis data set that's been developed and maintained by a core group of researchers at the American Museum of Natural History or affiliated with the AMNH in some capacity since the 1990s. The initial version was published by Mark Norell, who was my and Amelia's PhD advisor, Jim Clark, who was Alex's master's advisor, and undergraduate advisor, and Pete Makovicki, who was one of Mark Norell's first PhD students. The analysis has grown a lot over time, both in terms of the number of species included and the number of characters included. Major updates were published by Alan Turner and Steve Brusati at varying points in their careers, usually kind of as a culmination of dissertation work. This is a matrix that Alex and I built on while we were writing the Kuru paper.
And because
it's a great matrix, I think there are probably modifications that I, could and will make to it at some point. Every matrix is,
no matrix is perfect.
No matrix is perfect. They all need some scrutiny, but in general, it's got a couple of strengths. One is that it's had a lot of people working on it over time. And two is that it's been based on a tremendous amount of firsthand specimen observation. And so, this is a matrix that was designed by people who were by and large working with the actual fossils while they were designing their characters. And one of the reasons we're all huge proponents of open access scan data is that having the direct 3D thing to work with and visualize is really important for making these sorts of observations.
Makes a world of difference.
Right. And so the current scope of the matrix is that the outgroup is Allosaurus, and so what we are kind of testing are these things that are more inclusive, so Coelurosaurs. And because it's a Coelurosaur-wide matrix, even though this was the matrix that I used to place Curricula, like, we have data for a lot of other groups of theropods. There's sampling of every major Coelurosaur group and most of the important taxa. So we have Compsognathus scorings. And so I reran the analysis. I output the most parsimonious consensus tree.
Which means?
Well, I'm not going to define that, Amelia. So what you do under maximum parsimony, and we will make videos about systematics, but in brief, there are multiple optimality criteria, as we call them, for phylogenetics, which just means there are multiple different ways that different systematists will assess what the best phylogenetic tree is to describe the relationships of a group of organisms. The kind of oldest and most classic, and I think in many ways one of the best to use with morphological data, is just parsimony. And so what we are trying to optimize is we are finding the tree topology, or the shape of the tree, that invokes the fewest number of evolutionary changes. And so we will prefer a hypothesis where an evolutionary trait arises the minimum number of times. And you do that over all of the different traits that you're looking at. Philosystematus, how do you feel about that as a very brief explanation of what parsimony is?
I think that's
even briefer, like the idea is like the simplest possibility is the most likely.
Yeah.
So the fewest amount of evolutionary changes is
Occam's
the
razor.
simplest and therefore most likely.
Yes.
Exactly. Yeah. And that's a very, right. This is, like Scott said, Occam's razor, right? So this is a very old idea in science. It's not just applied here, but it's, invoke the fewest extra things that you don't observe.
Yeah.
Now for
the other half of that was the consensus tree part.
Yes, I'll get to that in 1 second. Okay. But yeah, the thing I just want to mention is that molecular phylogenetics have, because we kind of understand the way DNA evolves more, we have a lot of probabilistic models we can use to do various different types of tree estimation. We're getting to a point where I think model-based methods are becoming more useful for morphology, but generally speaking, the models that exist for morphological data give essentially equivalent results to parsimony, except in a couple of cases. So, like, right now we don't really have anything that's better to be using. And there are good philosophical arguments in favor of parsimony as well, regardless of performance and accuracy issues.
And the difference between parsimony and those is basically like, because we understand how DNA works, we understand what the more likely changes are, even if at face value they don't seem that way. Does that make sense?
So, well, I mean, yeah, I would. So I'm going to just explain it slightly differently. So with DNA, we know that, like, for instance, A, T, C, and G are the nucleotides that make up DNA, right? These are, these are just chemical compounds. They only match with each other, right? So A only goes to T, C only goes to G. There's different transition rates that are empirically determined between those bases. So we know relatively the probability of A changing to T is different than the probability of A changing to G or A changing to C. And the same with all of those. And so there are various models you can use in molecular systematics where you can actually mathematically work out the probabilities here. And what you're actually optimizing is a likelihood score, which is a statistical term that is like essentially saying, what's the most likely thing here, which has a strict meaning in statistics. Mm-hmm. That can invoke multiple changes at one nucleotide site, which may be mathematically preferred under these scenarios, even if you don't observe all of those changes. So you may say, like, hey, in aggregate, looking at all of this, we actually think this nucleotide changed 4 times, which parsimony would tend to not reconstruct, because that's not what parsimony is doing, right? Like, so the kind of difficult thing with systematics is that, especially when you have incomplete data, but just generally because these are such complex problems, right? Mathematically, the stuff that the computer is doing in systematic analyses is really interesting. when you have a certain number of taxa, I think it's, Alex, you may remember this number. I think it's 80 taxa, or maybe it's over 100, but not as many as you may think. There are more possible tree topologies than there are stars in the observable universe.
I think it's less. I think it's 60. Oh, is it 12?
Well, I guess maybe it's 12 is when it gets like just computationally infeasible to possibly get all of the solutions. I don't know about the stars in the sky number. That might be
no, I think it's over 60 or something.
Yeah, it's close to that.
Right. Like these are actually quite hard problems. Like there's a reason this is a field of study and not just like a test you do.
Yeah, and that's something that I think this and the fact that we're discussing it is worth our viewers to keep in mind, which is it's often, and this is not always wrong, but sometimes when a new phylogeny drops, people who are not versed in the methods might be like, oh, the new phylogeny. This is the answer. No. It is a new hypothesis of relationships, because that is what a phylogenetic tree is. It is a hypothesis of relationships. And, and this is not to say all matrices are the same. There are things that make some better than others. It's all about how characters are constructed, scoring issues, how, taxa are sampled, stuff like that. And so, just because it's new doesn't mean it's right, but it also doesn't mean it's wrong. You kind of have to, it can be challenging because unless you're pretty intimate with how these matrices work, you are kind of unfortunately in the position of, well, I kind of got to take, the word of the consensus on this.
Right. And I mean, there are also things you can look at, like how were they run? Like, did they use the optimal tree search parameters for the heuristics that we do, right? We're not just trying every possibility because, as I said, when you get above a certain number of species on the tree, there are literally more potential trees than there are stars in the observable universe, right? I cannot understate this. So you're not just making every possibility and seeing how good it is. That would be, this would essentially melt your computer or take, weeks, 2 months, 2 years of time, depending on what kind of equipment you have. For parsimony, we generally don't need supercomputers to do the work. Although, like for molecular systematics, it's very common to push these jobs to a supercomputer to do math a lot more effectively. But like, you need to know what the tree search parameters were. We need to know how the analysis was done. Like these things all matter. But what I was getting to with that is that because of these issues, you can actually have multiple tree topologies that are equally parsimonious or equally well supported.
What?
Right. Because especially in the case of incomplete data, like for instance, let's say you've got one thing that's pretty well preserved and you've got one fossil that's just got a head. Like it's like you've got one thing that's a full skeleton. You've got one thing that's just a head. And then you've got another thing that's just feet. And in each of those cases, there's one character difference between the head and the foot and this very complete thing. It's only one trait different, but it's one head trait different and one foot trait different. These would be reconstructed as equally likely or equally parsimonious as the closest relative of this animal. Right. And this is like, it's not always necessarily one trait, right? There are often many topologies that will give the equivalent number of evolutionary trait changes over the tree based on what's observed, what's scored, how things are scored, and all of that. And so instead of presenting every possible tree topology, which is impossible, especially because many like very incompletely known taxa tend to jump around, we compute what's called a consensus tree. And there are multiple kinds of consensus trees, but the one I used here is called a strict consensus. And a strict consensus is just, this is what all the trees agree on. I'm specifically using a reduced strict consensus, which is essentially telling the program, get rid of the wild card species, and then tell me what all the trees agree on. And I'll give you an example here for this analysis. I just need to open up one of my data sheets.
Isn't this fun?
So it is fun.
It's important.
It's important, and you have to learn it. So Atrociraptor. Right? Remember Atrociraptor from a few episodes ago? I don't know how many episodes ago. Remember when?
Remember when is the lowest form of conversation.
I was about to say it. So Atrociraptor, as you may remember, is known from only 3 bones. It's known from a premaxilla and a maxilla and a dentary. From these bones, we are certain that Atrociraptor is a dromaeosaur. However, there are many equally parsimonious positions within Dromaeosauridae that it can occupy. And so we consider, in my analysis, Atrociraptor to be a wild card, and so we remove it from our final tree topology. We don't remove it from the analysis because its morphology has information that we want to go into the analysis, but then we don't want the fact that it can occupy almost any position to be collapsing the entire clade into what we call a polytomy. And a polytomy is what you see in a strict consensus where there is not an agreement among the trees that you are putting into it.
Bush.
It looks like a comb, right? It'll be things that are not splitting from a bifurcation point when you see three or more things arising from the same branch.
It's just telling you,
right? I mean, we don't know.
We don't know what is more right, because
right. I mean, within that group, we don't know what's more closely related to what.
Exactly.
It does not mean that everything in that group is most closely related to each other. It's just saying that there's disagreement among the possible trees of how they are related to each other. But it's not saying that, a wipeout of that group is
unless it's unless it's a hard polytomy,
which may or may not exist.
Yeah.
Right. Right. But I think we can leave that there. So, but the reason we prune the wild cards is that because Atrociraptor could occupy every possible position within dromaeosaurs, if you include it, we then must say we don't know how dromaeosaurs are related to each other.
How any of them.
But how any of them are, because Atrociraptor could go anywhere within there. But if we say we're not considering Atrociraptor right now, factoring that out, what do we agree on? And we do this with a couple of other fragmentary species in the analysis, you suddenly see a very well-resolved tree topology, where what we're effectively saying is, like, if we don't consider these, we know Velociraptor and Shri are each other's closest relatives. We know Kuru and Atosaurus are each other's closest relatives. We know Microraptorans exist. We know Unlagians exist. And we know that Mahakala is an early diverging dromaeosaur. It's just that Atrociraptor can go anywhere in there. Another former channel feature, Pyroraptor, is even worse. Pyroraptor can, go anywhere within there, really. I think Atrociraptor only goes within, like, derived dromaeosaurs. But I think there are some topologies that we get where it, like, even winds up as a Microraptoran, which is probably not right, but analytically we can't say that that's not right. Pyroraptor could literally be the closest relative of any dromaeosaur that's in the analysis. So we cut it out.
Phylogenetic hyperposition.
Exactly. It is simultaneously related to everything. Dalton, I saw you were trying to say something, and if you need to interject here, please do before I keep going.
The point was made.
Okay.
So.
Okay. So I reran the analysis, and I've mapped out the synapomorphies of major clades to take a look at the traits that actually wind up not only placing Compsognathids within Silurisaurs, but that in this analysis find Compsognathus and these other small-bodied theropods to form a clade or a natural group with each other, which would indicate that they are to some degree a real group. There's a lot of traits, and I'm not going to go into them all because a lot of them are, like, fairly esoteric. And again, the data set, you can actually find my email in the paper. If you want to do this with the data set on your own, I will send it to you. Like, it is openly accessible. There's just been issues with getting it up on one of the repositories, but if you email me, I will send it to you. I've done this for colleagues. It's a freely available data set. One thing that Compsognathus does not have that non-Silurisaurs tend to have is a posterior process on the quadratojugal bone of the skull. Right? When you look at it in lateral view, the quadratojugal is just kind of L-shaped like this instead of T-shaped with another process going posteriorly. We'll have an image for this. I'll find one after the episode, and we'll put it in the editing room. So again...
Maybe it'll even be Compsognathuses.
Maybe it'll be Compsognathuses. That process of bone not being there is one of the things that is placing Compsognathus as a Silurisaur. Within Silurisaurs, one thing that we find placing it higher up within the clade, so to speak, are the degree of episthocele in the... I'm sorry, this is a bad example. Let me look at one of the better things right now. Okay, one thing placing it up a little bit higher is that the ascending part of the maxilla, what we call the ascending ramus. This is what's coming off of the horizontal bar of the maxilla.
It kind of makes the side of the face.
Right, it makes the side of the face.
It's the side of the face.
it's very long in relation to the height of the maxilla. This tends to be a derived Silurisaur trait. Okay. On the astragalus bone has a horizontal groove at the base of the ascending process. So this is forming the ankle roller. In dinosaurs, there's a characteristic triangular ascending process that goes up and overlaps the shin bone. There's a horizontal groove on the astragalus there. That trait is found, or is only found. Hold on, I'm just taking a look. Wait. Oh, I looked at the wrong character and I said, why is that invariant? That trait is, for instance, not found in primitive tyrannosaurs. It seems to independently emerge in derived tyrannosaurs, but then is found in all of the major groups of later diverging Silurisaurs.
And that limits the rotation of the ankle, right? Is that
the horizontal groove? I don't think so. That should probably just be that's probably a muscle insertion or a vascular structure or something. But again, this is not found in Allosaurus or Sinraptor, these carnosaurs that we use to outgroup the analysis. It's not found in some of these very primitive Silurisaurs. It is found in these more derived, later diverging Silurisaurs. One other thing that's quite interesting is that, and this is a derived Silurisaur trait, or I should say a Silurisaur more derived than Tyrannosaurus trait, it doesn't have a pneumatic recess in the lacrimal. Right, the lacrimal seems to not be perforated, at the very least, by a very large sinus opening that you can see in lateral view. You can see this really well in Tyrannosaurs, for instance. It's not present in Compsognathus. The jugal bone, as it meets the maxilla anteriorly, tapers instead of expanding or being blunted. That's a more derived Silurisaur trait. So there's a lot of these things that are actually quite characteristic of being a Silurisaur and not an extremely primitive Silurisaur. Taken at face value, I don't think that this leaves a lot of possibility that these animals are not Silurisaurs, as has been suggested by some recent scholarship. Right? Like, they would not have synapomorphies of this group. That's not generally, like, ontogeny will not give you synapomorphies of an entirely different clade.
Yeah, this is, and I think we should say, this isn't to say that they're not young.
Right.
And they, like, yeah, some of them could be juvenile. There are, and I'm going to perhaps go out on a limb here and say, poorly defined and resolved features of juvenile dinosaurs that have been attributed to Compsognathids. But the actual, like, there are maybe 2 or 3 robust ones that apply to at least Compsognathus.
Yeah.
A lot of them are just kind of like, this has been reported to be a feature of young theropods in X or Y.
Yeah, this is something that Ostrom talks about in his osteology of Compsognathus, that he clarifies many, many times. I swear it reads like it's almost every other sentence. It was just like, there are 2 of these. We can't really ask. We can't really make a good estimate of if this thing is a juvenile or not. But this is specifically in reference to the Munich specimen. And he seems to indicate that the piece of evidence that is most likely to be evidence that it's a juvenile individual is that its skull orbit length index is really high, indicating that it has like a very, very large orbit for the size of its skull, which if you see baby animals, they have bigger eyes proportionally to the size of their head. But he also does, again, couch this with, this can also just be a thing that animals have.
Right.
Yes.
Yeah. Well, I was just thinking of just a couple weeks ago, there was a paper on the big eyes in certain kinds of mosasaurs. Like it's, and they look really silly and they look really like a baby, but they're not. Like, that's just how they are. They've got huge eyeballs.
Right. And I mean, so some of this could be ecological, right? Like, obviously we might speculate Compsognathids were nocturnal from that. One other thing that I think,
deep divers.
Compsognathids,
there
they've got flippers. They've got obviously.
Oh yeah, they're going to the
right.
deep sea.
But here's one other cool thing. Coelurosaurs as a clade are kind of defined by a general pedomorphic tendency as you approach the origin of birds. And pedomorphosis refers to an evolutionary process in which novel morphology is generated by the retention, essentially the retention of juvenile traits into adulthood. It's a little bit of an oversimplification, but it's a decent way to think about it as a kind of a first order introduction to the subject.
Like
axolotls are an extreme example of this.
Right. And humans relative to other primates are another example, right? Like our adult morphology more resembles the juvenile morphology of a chimpanzee or a gorilla.
Like a lot.
Our eyes are relatively larger. Our jaws are much less developed.
Our canines are much smaller as adults.
Yep.
Right. This is, and I mean, it's also interesting because one of the main things that happens in development is like there's generally negative allometry of the head relative to the body. So generally the brain is relatively larger in young animals. And I've heard it at least speculated that there might be some general trend where lineages that are characterized by relative brain volume increase in adulthood are going to be pedomorphic because that's going to be like if you're trying to retain a larger brain, one of the obvious things is like delay that developmental pathway so that you don't have as much relative brain size loss. And this would also play in very nicely with what's going on in birds, right? Like we see a general tendency where the relative size of the brain in even adult theropod dinosaurs is increasing along the line to birds. And that's accompanied by a pedomorphic character displacement where progressively more derived coelurosaurs tend to look more like juveniles. And so large eyes are another example of this. And obviously body size is something that tends to increase during ontogeny. And so it's also possible that Compsognathus are pedomorphic as a lineage, and that this kind of pedomorphic trajectory is responsible for both large eyes, generally kind of having baby-like proportions, and being small-bodied.
It give baby.
Now, it gives
does
baby.
Give baby.
One thing I should say is that there is some decent evidence that a lot of these are not skeletally mature. Like,
yes,
I don't
absolutely.
think any of them have been reported to have fused neurocentral sutures, and at least even the anterior-most caudal vertebrae. This is a complicated area, but generally the neural arch of the vertebra, which is the part on top above the spinal canal, fuses to the centrum, which is the body of the vertebra, during development. There's some sort of a switch that happens during archosaur evolution where crocodilians fuse the ones at the end of the tail first and move forward. And by birds, you start fusing them at the tip of the vertebral column near the head and move backward. We don't really know where that switch is happening and what that looks like. We do know that dinosaurs were also fusing their neurocentral sutures during ontogeny, but based on personal experience, it doesn't seem like they fuse to the sutures remain visible until quite late in development. And so the presence of open neurocentral sutures in a fossil does not mean it's a baby. It just means it's not fully mature, which is a very different statement, right? Like I've seen that beautiful Gorgosaurus at the Royal Tyrrell Museum that's preserved in the death pose has visible neurocentral sutures. It's known to be a subadult. It's not fully grown. I wouldn't call that a baby, right? That's a fairly large animal.
But does it give baby?
It doesn't really give baby, no. It's just, I mean, it's, I don't know, it's maybe like 2/3, 3/4 grown. Like, you know, if Compsognathus was 2/3 or 3/4 grown, maybe it's getting to the size of a dog. Right.
And there's evidence for this with other Compsognathids.
Yes. What are you thinking of?
Sinocalliopteryx, Compsognathus,
right?
Which are sizable, not giants by any measure, but you know, Compsognathids, and they're
right. They're like velociraptor sized. Yeah.
Yeah, and they're also
Compsognathus is only a little bit bigger than the French specimen.
That's true. Yeah, Sinocalliopteryx is really the very large one, but even as a very large one, like again, we're talking about a velociraptor-sized animal, which is, you know, not huge, but also not something that we have any difficulty with interpreting as an adult. Like you know what I mean? I will say,
James,
what?
I wanted to say, Ostrom does note that he does see at least what he thinks to be fused intercentrum sutures.
Neurocentral or intercentral?
intercentrum.
So that would be between the vertebrae, not between the vertebral body and the neural arch.
Oh, did I fuck up what you said?
You may have. I don't have the paper open right now.
Ostrom did make a few mistakes in there too. I think not Carpenter. Who did the Coralestris redescription?
Pear.
I think they say something about that.
I actually checked. I didn't find it, but I was skimming it right before recording, and I may have missed it.
Okay, maybe I'm misremembering.
I've got one further note here.
Yeah,
sorry, dude.
Well, two further notes. No, it's okay. And I'm almost done. I apologize for the extremely long stun lock.
No, it's important. Even though you've
stolen
Phylogenum
it's a
from
feature.
Me.
I did real science for a long time.
For like maybe 20 minutes.
25 minutes. So
how long does it take to write a paper? 20 minutes?
20, yeah. Scott, it's good that you asked that question. So there's a few character conflicts within Compsognathus, which in my analysis is interpreted to be a full polytomy, so we don't know the internal topology of the group. But my analyses consistently find Compsognathus to form a group with Sinosauropteryx, Sinocalliopteryx, Quacks, Juravenator, and Miritia. So these animals in my analyses are coming up as a group. And it's possible that some of this will change as more data and more species are added. They are not identical, obviously. One thing that is different within them are that, at least among the things we can score this for, Compsognathus has, and let me make sure I get the states right here. So Compsognathus has strongly episthocoelous cervical and dorsal vertebrae, which means that the concavity in the vertebra is on the back side, not the front side. Okay, so the front side is forming kind of a convex ball to articulate with the vertebra in front of it. The back side of the vertebra is forming a concave cup that's meeting the ball of the next vertebra. So that's what a strongly episthocoelous vertebrae look like. Sinosauropteryx seems to have either weakly episthocoelous or amphiplatian vertebrae, where both sides of the vertebra are flat, and so they just meet as kind of a flat articulation rather than a cup and ball. You may say, hey, the fact that those are different means they couldn't possibly be close relatives to each other, right? But several tyrannosaurs, or tyrannosauroids, I should say, have strongly episthocoelous vertebrae, and others have amphiplatian vertebrae.
What?
I know. It's well, and it is interesting. It's not clustered. Like we see what appear to be strongly episthocoelous vertebrae in like Dilong and Eotyrannus and Timmerlengia. The rest of the clades seem to have amphiplatian or weakly episthocoelous vertebrae. And this is also variable in a couple of other clades as well. Alvarezsaurs seem to show some variation, and it's actually only Alvarezsaurs where they appears to be variable as well. So what I'm saying here is that having character conflict within the clade does not mean that these are not close relatives. And there are also several characters that these animals share. I actually have, let me count here, 12 synapomorphies out of the 800 and something characters in the analysis, which is pretty good, that unite these animals together. So for instance, the morphology of the retroarticular process of the articular bone that sticks out from behind the jaw to receive the depressor mandibulae muscles that open the jaw up. Another one just kind of taking things, with no particular scrutiny here. So character 124 in the matrix, the presence of ossified sternal rib segments. That is, by the way, something that seems to indicate relative maturity, at least in my eyes. You tend to see increasing ossification as animals grow up. So character 175 in the matrix, the absence of an anterior process of the pubis. So there's not a boot with an anterior and a posterior projection, it's just a posterior projection. Like, these are things that are shared among the members of this clade for which we can actually score the characters. So if the morphology is present, that's what we find. I certainly don't think it's a bad conclusion to kind of conclude from this that these animals are close relatives and form a group with each other. That's not to say that future analyses will always support that. They may not. And I'm not making a definitive argument here that like this is the only possibility that exists. But I think the what I see online in the kind of paleo community right now is like what appears to be illusory confidence in the fact that we know this relationship is artifactual. And I just I don't really think that it is necessarily, or at least I'm not looking at this and seeing, yeah, there's no way this is real. This must be some weird artifact of ontogenetic stage or bad character definition or what have you. Like there's no warning signs jumping out to me here. And other theropod specialists here, you may feel free to disagree.
No, I mean, I agree. I think there's something to be said that, you know, some of these might be juveniles. Some of the stuff that maybe has been referred to Compsognathus could possibly be other stuff. Like Cirrhomimus, for example, is Compsognathid-like. And it's been referred to megalosaurs. So possibly. I think Compsognathus and most of the stuff that actually falls out in Compsognathus are almost certainly Silurisaurs. And I think at least Compsognathus and a few others form a actual natural group. There are synapomorphies for the clade, which have been referenced. Again, they have these kind of fan-shaped neural spines on the dorsal vertebra. That's the one that jumps immediately to mind. There are others. And yeah, there are a few lines of evidence. There is some evidence that suggests even some of these smaller ones are possibly adults. Eggs in the Sinosauropteryx, although the actual preservation and taphonomy of these are a little contentious. There is the unnamed Brazilian Compsognathid, which has like display feathers.
It used to be named, if you're confused.
Yes, it used to be named. But that has display feathers, which are not a juvenile feature.
Is it no longer named?
Well, it was named. It was retracted because it was unethically done.
Okay.
But yeah. So I think when people are discussing Compsognathids, unfortunately, a lot of the conversation is made in these kind of sweeping generalizations that I don't think really bear much scrutiny.
Right. And I mean, I think it's also important to note, like, they don't have to. I hear a lot about this idea that Sinosauropteryx is a juvenile Eutyrannus.
Oh God!
Mm-hmm.
Right.
Save me, God, save me!
It's not like it. Just they don't share traits. Like these animals are in the analyses together a lot. This actual particular version of the analysis does not include Eutyrannus, but it includes several very close relatives. Like, if these animals were sharing a lot of traits with each other, it would pull Sinosauropteryx at the very least into there. It's a well-known pattern in systematics that juvenile animals tend to wind up pulled to the bottom of the clade that they're in because many synapomorphies of increasingly derived groups may appear toward the end of development. And it's like, this is well observed empirically. When that very young baby Tarbosaurus was described in 2011, I believe, they scored it in a phylogenetic matrix, and they found it doesn't really go near, it doesn't clade out with Tarbosaurus adults because it hasn't yet acquired all of its traits that it gets developmentally. But importantly, it still gets recovered as a Tyrannosaur. Like, you're going to go toward the base of your clade, but you're not going to hop over to a different one. And so I think if my interpretation at the very least is that if these animals are really juveniles of other theropod clades, we must primitive. They'd have to be incredibly primitive, and we'd need to really be misunderstanding a lot of theropod evolution. Or rather, we'd be misunderstanding a lot of theropod ontogeny if these animals are going to other clades. So my interpretation is, I don't know, I certainly buy them as a clade. You know, as more discoveries and more interpretations and more characters are made and discovered and codified, maybe they won't be. Nothing's an impossible result, but there's certainly no reason to be looking at these analyses, or at least my analysis right now, and be thinking, yeah, there's no way this is a real group. This has to be a bunch of different kind of unrelated juvenile animals. If that were true, like, It just doesn't really map with how systematics is done because they share synapomorphies with each other.
Right, like the whole reason they're coming out together is because they have things in common. They share synapomorphies. If you're sharing synapomorphies, you tend to be related.
Right.
Like, obviously there are cases where, like convergent evolution, where you can have characters that are in common because it's like the animals are evolving similar features because they're dealing with a similar environment or what have you. But like the kinds of anatomy that you were describing earlier that's holding this clade together is not things that you would expect. Like convergent evolution is like, oh, when mosasaurs get big, they all tend to get really beefy ear bones because it's a large animal with large soft tissue in that area. It's not the shape of the pubis or whatever. It's or the vertebrae, like it.
Yeah, and I mean, I think this is something that I think a lot of people in the broader paleo community, but who don't do research, may not realize. I think systematics is often looked at as like bringing together things that are similar. And so Alex, go ahead.
Which is just like the fundament, like a fundamental misunderstanding of phylogenetics.
Right, like it is not
cladistics, I should say.
Right. It is not similarity. Like that's a prior approach called phonetics that was shown to not work. Right. You don't do it by actual anatomical similarity. You do it by possession of unique derived characters. And that's why like baby animals do tend to all look similar to each other. And even in very young animals, you'd expect to at least have traits that allow you to determine what broad group of animals they belong to.
I've been thinking, like, if you take like all the cats in the world, right? Like their kittens and cubs look fairly similar to one another. Not that I'm saying you wouldn't be able to distinguish them, because you could, but they all look fairly similar. But like they don't look like baby bears, and they certainly don't look like baby like horses.
Right. And so maybe if you had a skeleton of a lion cub, you wouldn't be able to know for sure if it was not a leopard cub or a tiger cub or a jaguar cub. But it's a cat.
Ain't a whale.
Well, you might not know that.
Yeah, that's fair.
Right.
And this is like why I hope you do get screenshots to show of the mesquite trees, because something that mesquite shows is actually the character change over time. So it's showing you the actual distribution of the anatomy on the tree, so you can see like why these things are grouping together in a sense. Like obviously there's all the math behind it, but like the way it's visualized, like you're seeing the animals that have this anatomy and don't have this anatomy, and it kind of just better visualizes what the analysis is actually telling you and how it's actually tracing the anatomy and how that's informing how these things are being hypothesized to be related.
Right. It's a really important thing. And like, that's why what I'm saying is baby tyrannosaurs have been documented to be recoverable as tyrannosaurs.
Yep.
You would expect that if Sinosauropteryx is a baby tyrannosaur, it would be recovered phylogenetically within that clade, even if it wasn't uniting as the sister taxon to its own adult form. Right. And like the degree to which this happens is dependent on like how many of the characters that we are using in the analysis do appear during ontogeny. And the answer that's been kind of empirically demonstrated in a lot of these cases is some, but not all. Like, which is kind of what you'd expect, right? Like, if we're basing things on the adult morphology, the babies will not have the adult morphology. But the babies are not going to be just indeterminate. There's going to be at least something you can use to determine relatively where on the tree they go. So, that's my spiel. I'm sorry to steal Phylogenum from Alex. Oh, by the way, Phylogenum Compsognathus is a compsognathid, and compsognathids appear to be a relatively early diverging clade of coelurosaurs. According to, well, what?
No, I mean, you're just right. That's, I just wish I was saying it. And sometimes they're found to be closer to birds than tyrannosaurs, and this group is sometimes called Maniraptoromorphs.
Yes, and this is, by the way, the topology that we get in the Karur analysis. So in our analysis, the earliest diverging group of coelurosaurs are the tyrannosauroids, and then compsognathids are the next major group branching off. There are a couple of kind of poorly known and enigmatic animals that seem to be between them.
Yes.
But as of yet, we don't have evidence for a broader group there. There might be. I mean, I'm sure there's clades that we haven't discovered, but As of right now, that's the topology. And so we have Compsognathus branching off, and then after that are Alvarezsaurs, Ornithomimosaurs, Therizinosaurs, Oviraptorosaurs, and then Paraves dividing into Troodontids and Dromaeosaurs on one hand and birds on the other. And that is the evolutionary step. And so the characters I went through for this are essentially what are pulling these above Tyrannosaurs in the tree analysis, and then what traits are uniting them with each other. And like, I guess no, I can't do this fast enough, so I won't do it now because we need to wrap the video pretty soon. So, but you know, there are obviously also traits that are shared by Alvarezsaurs and Ornithomimosaurs and all those other clades that are not seen in Compsognathus, which is why those animals are found as being more derived. Right? That's
how it works.
How systematics works, baby.
That's how it do, Yugi.
That's how it do, Yugi.
Well, I know we've talked an exceptional amount about this design. But unfortunately,
that's the point of this video.
Schedule complaints do require that I need to go to bed in about 20 minutes at the.
All right, design time.
Can we rank it and maybe comment on the design a little bit while we do that?
Let's take it to the species group.
I appreciate that.
Take it to the phone.
Well, folks, how do we feel about Compsognathus in Jurassic World Evolution 2?
Well, Amelia, you go first.
It's so small. It's so bouncy. I don't know. I don't have like much interest in this group or these animals, but like I really like it. It's cute enough, but it's devious. And like I really like the little puppets in the movie. And this is basically the puppet, so I'm going to treat them equivalently. It's like the only reason I ever want to watch the second Jurassic Park.
Only reason?
I don't like the second one at all.
What?
I don't.
I'm very surprised by this.
We can have this argument another time, or discussion another time. But when I shared my rankings of the Jurassic movies in the Patreon, there was an uproar.
I'm sure everyone behaved very normally.
It was very normal. No, it was fine, but they were shocked and appalled. I'm like, these are not opinions that I've ever hidden. It doesn't matter. I like this little guy. I like the little puppet. I like that it's a menace. And this is the thing, I mean, in the book, right? Like, this is the thing that it opens with, basically. Like, this is the little guy that's sent to the lab and everything. Like, I mean, not technically, it's the Compsognathus or whatever, but, like, it doesn't matter. For the purposes of the canon, it is this little green beast.
Does it open with this, or does it open with the worker going to the hospital for the raptor?
It opens with the worker.
Yeah, but this is the second.
No, I'm just saying, like, the first plot point is there's this weird animal that's been sent to New York, and they don't know what it is, and something is eating babies. Like, that's kind of the main. Like, yeah, it opens with the more shocking thing, but like the initial plot that kind of gets everybody involved is this little green thing in New York.
I don't know. I'll say the image in the book of like the nanny opening the door and the Compsognathus illuminated by moonlight looking at her with like the glowing eyes, reaching down and ripping a strip of flesh off of a baby is, I'm gonna say, a bit shocking.
I know. I'm not downplaying it. I'm just saying, like, sure, the first opening scene is not this, but this is what I remember as the beginning of the book.
Yeah.
I don't know. It's hard for me to rank it because I feel like it is an H, except it's such a devious little shit. Like, there's no way. It's too evil. Like, untrustworthy. I don't,
Do not trust like that.
I don't trust these things. They're destructive. They're not law-abiding citizens. But I do. It's an S for me because like it's not inherently good enough to belong in H, but I think that it's perfect in terms of design for this kind of animal and for what it is and what it does in the movie. Or in the movie, like I said, it's in the third one too, isn't it? Technically, kind of.
They appear a lot in the background,
Yeah.
I don't even remember
shots.
Yeah.
Yeah, if you actually look really closely when the T-Rex and Spino are fighting, you can just see compies like running around their feet.
And they're over at,
it's a great little detail.
There's a bunch of at Eric's truck that he lives in.
Yeah.
Yes.
Mm-hmm. Yeah. There's a couple little close shots of him, but not many.
Yeah. So I think as a design, I think this is, I don't know, it just is correct to me. Feathers or not, I don't care, I think it's great. Yeah. S.
So I love the movie design. And I think if this were exactly the movie design, I would make this an H, because I think the movie design, like the puppets they made for the movie, are stunning, and I love the motions they give them. Like they get little animal twitchy motions really well. And
Very
I think
birdie.
that lack of feathers aside, they are very birdie. And I think lack of feathers aside, it wouldn't be a bad reconstruction of the animal. Like, it's not necessarily how I would do it, but I'd say, like, it looks pretty good, right?
Mm-hmm.
And they look very lifelike and very well realized. I don't feel like the Frontier model really captures some of the, like, nice details of the movie puppets, which is probably a consequence of its small size, but I think for me, that's going to bump it down. And I don't know if it's bumping it down to an S or a high A.
I see.
I think I'm going to let it go. I'll be nice and I'll give this one an S tier as well, because I am very, like, fond of this as just generally an animal. But I do just wish that it was a little bit more accurate to the movie model, because I think the movie model looks really good.
Does it slay?
I love this little guy so
It
much.
slays.
It's so delightful, and I like its little mischievous energy. It really brings joy in the chaos. That it's like, whenever these guys show up, you know that bad shit's going to happen, and it's going to be their fault, and they're going to be. It gives, like, honestly, it gives, like, parrot or crow energy a little bit of, like, they're smart enough and small enough that they can get in a bunch of places where they're not supposed to be, and they know the difference between right and wrong and actively choose to do evil.
They're ne'er-do-wells.
They are, absolutely. And I really, as well, with just the game model itself, they gave so much personality to this little guy. Like, the fact that it skips as its primary walking animation
That is fun.
is so delightful. They're very cute. The sounds they make are basically just the canon sounds that I imagine small dinosaurs make. They are just absolutely wonderful. If anything, the only thing that I would critique the game model for, and not even the game model, is I wish that when they added the insect feeder in for Jeholopterus, if they allowed Compsognathus and some of the other smaller theropods to eat from it, because I think that, one, that would be some phenomenal little animations that they could throw in there, and two, having just the one static meat, like, model for all carnivorous dinosaurs is very funny when they have, like, slabs of steaks that are 5 times the size that this guy is that they're feeding them. It's just very goofy. Oh gosh, I forgot as well. I like them as well because they were one of the first ones that had the pack hunting. Like, you can feed them goats and stuff, and they latch all over it and tear it to pieces.
Right.
Oh, that's another. Yeah, they do that to people too. And another thing that we said we were going to mention in our little pre-recording strategy thing, in the novels, and they mention in Camp Cretaceous, they say that Compsognathus were mildly venomous. This is not the case. There are no venomous dinosaurs known.
Indeed.
But I'll get this.
That's a holdover in the show from the book, right?
It is. Yes. They even give a little bit of lip service to that. They actually, like, as kind of throwaway dialogue between some scenes, say, like, it's like, I heard a story a while ago that, like, some weird eccentric billionaire was killed by a bunch of these at one point. And they were just like, where'd you hear that? I don't know, some book. And then they never reference it again.
Oh, that's fun.
Cute.
Wow. Imagine if that show were consistently
interesting.
Good.
Yeah, that'd be great. But so I'm going to wrap this up and give this guy's an H. Diabolic little monster, and I'll end with the final point of it is shocking how different the vibes are between a scaly and a feathery version of this, because Sinosauropteryx is basically almost the same creature, and it is wonderfully fluffy, and I would trust that thing with my life and die for it. This thing would try to kill me.
Yes, this is, as I've said before, a ne'er-do-well.
Absolutely. But an H. Nonetheless.
I love the Stan Winston little puppets. It's got a great design language to it. It's a fun retro Compsognathus. That being said, as Jimbo pointed out to me, I do slightly prefer the film version, but this is still pretty cool. And I mean, I think it would be cool if they had feathers, but that's not what we're going for. We have Sinosauropteryx. I'm happy to give this a very high A. That's it. That's all I gotta say.
Yeah, this is a creature that you would find at a sewer grate or some other dark opening on the side of a road that might outstretch its neck, perchance for you to give it a scrap of some kind of detritus, a bit of salami from your sandwich that you weren't going to finish.
Pass the detritus.
This is some kind of goblinoid little freak, and I like it a lot. I love the compies in Jurassic World. They're so cute. They've got so much personality. They're so fun the way they move, and they just kind of all look a little bit emaciated and a little bit kind of grungy. And I think some of that is lost in this model a bit. I think that might be what isn't translating from puppet to this, is that this looks almost too healthy compared to the puppets, which look a little bit starved in a way that suits the design a lot. But I like, this is like, for better or for worse, like I know that Compsognathus had feathers, but this is like the canon Compsognathus for me is this little creature. And I actually really like all of the other color variants that we were seeing in the park, in the Solnhofen there as well. I think they all work well. I like the social animation. I don't have any problems with it, like really anatomically. That the hands are wrong and it needs feathers, but like beyond that, it's really not egregious. I think the one thing that would benefit it's not even his fault. It's just that every kind of foliage and every kind of foliated ground has grass in this game, and the grass is taller than these. So like I don't actually use them very much when I play, because they just might as well not even be in the game. They're just invisible, and it's so hard for the staff to interact with them, to like if they get sick or hurt or anything. It's just like I was trying to move some when we were setting this up, and it was taking the automated helicopter so long, even on the maximum fast forward speed, to be able to trank one of these things. So they're a bit hard to play with in the game, and that kind of impacts maybe their rating a bit too. But I don't know that I can fully put this in H, but I will certainly give it an S.
Okay, well, with our flying colors of rankings here, I think that pretty definitively throws this guy up in S tier.
It seems that way.
Indeed.
Where it belongs.
Where it belongs. He's in good company up there. Well, let's see if that company is expanded any when it is time to
spin
that
wheel.
Round and round and round it goes. Where will it end? Nobody knows.
Oh
no.
No, God.
It had to be.
I joked about this a few days ago. The last stegosaur.
The last melon. Great, I can't wait. All right, see you.
Yippee!
Wait, Alex, you can't leave yet.
No, I'm not actually. I'm just communicating my displeasure.
I can't wait for us to record the short.
Yay, Shankangosaurus.
You know what the worst part of this is? I gotta try and come up with a silly and or otherwise engaging tweet about it for our social media.
I think, I have a joke for you to steal, but I'll talk about that after this because I don't want to spoil the video.
Did you know
but hey,
Compsognathus exists?
Yes. But did you also know that our patrons exist? And if you've made it to this point in the video, thank you for watching. You seem to really like our stuff. Would you potentially be interested in becoming a patron of the Skeleton Crew? If you do, you'll be able to hang out in our Discord server, which has recently surpassed 100 active members, which is really cool. An amazing milestone that I still can't believe we hit. We've got a wonderful community, and you'll have access to a bunch of exclusive merch items, various other benefits. And in the future, as we start actually making them, which will be fairly soon, documentary watch-along audio tracks, so you can hear our thoughts on various old paleo documentaries that you may want to hear us talk about. Right now, our most generous patrons who support us at our Gorgosaurus tier or higher, that's $25 a month or more, are Benjamin Seepser, nickname, original username, Philip Fico, Christopher Bellis Jones, Aaron Anderson, Adam Molos, Camphibia, Dano Kairos, Dinodom, Griff, King Zashu, Kyrie Spangler, Max Ironpaw, Pythonic, Ryan Steed, Swamp Ape Science, Wanderer, and Wheat. Thank you all so much for your amazing support of the Skeleton Crew. That list is longer than the last time I read it, and that's a nice thing to see. So thank you all so much. We hope you like this video. Remember, if you like it, please drop a like on the video, leave a comment, tell us what you think, tell us if you agree with our ranking. Tell me if you agree with the insights on my own phylogenetic analysis. I am really thrilled to hear other people's opinions of my work. It will be... surely you will be contributing something I haven't thought of before. So please, just tell me.
Humble.
Yeah. And if you do stump me with a question, we'll give you a shout out in the next video.
We simply won't acknowledge. He won't acknowledge it.
I will never acknowledge it. Anyway, thank you all. We'll see you next time with the last Asian stegosaur.
The last melon.
Bye-bye.
Bye.